Welcome back to another Thanks-Free video, where we dive into the stuff that keeps scientists up at night and makes your brain do backflips. Today's topic sounds like the plot of a sci-fi thriller, but it's very real and creeping up faster than you might expect. We're talking about quantum computers. How they work, why they matter, and the terrifyingly awesome potential they have to completely break the internet. Yes, I said break the internet. And not in a celebrity broke Instagram kind of way. I mean the literal foundations of cybersecurity crumbling like a poorly baked cookie. Before we launch into the quantum void, go ahead and smash that subscribe button like you're applying brute force encryption to your algorithm. It won't protect your emails, but it will make you smarter one Thanks-Free video at a time. Let's begin. Alright, let's start with the basics. What is a quantum computer? Because if you've only heard the buzzword and pictured glowing cubes floating in dark rooms with techno music playing in the background, you're not far off, but you're also not quite there. Classical computers, the kind you're probably using right now, work with bits. These are binary units of information, ones and zeros. That's it. Everything from cat videos to nuclear launch codes is just a giant stream of ones and zeros getting shuffled around and calculated very quickly. Quantum computers, on the other hand, use qubits. A qubit is short for quantum bit, and here's where it gets weird. A qubit can be a 1, a 0, or both at the same time. This is called superposition. Imagine flipping a coin and having it land on both heads and tails simultaneously. That's kind of what a qubit does, except it's not a trick, it's quantum mechanics. Now throw in another quantum principle called entanglement. This is where qubits become linked in such a way that changing one instantly affects the other, no matter how far apart they are. Einstein called it spooky action at a distance, which is also what I call my internet connection at 2 a.m. With superposition and entanglement combined, quantum computers can perform certain types of calculations dramatically faster than classical ones. But here's the catch, they're not just better versions of your laptop. They're a completely different kind of machine. Like comparing a bicycle to a teleportation portal. Both get you places, but in totally different ways. So why does this matter? Well, most of our modern digital world runs on encryption. Every time you shop online, log into a bank, send a private message, or just browse the web, encryption is working quietly in the background, keeping your data safe. And this encryption relies heavily on the fact that certain math problems are really hard to solve, like factoring huge numbers into primes. To a classical computer, factoring a 300-digit number takes longer than the age of the universe. To a quantum computer? It could do it in seconds. Maybe minutes. This is called Shor's algorithm, developed in the 1990s, and it's a quantum algorithm specifically designed to break RSA encryption, the foundation of much of the internet's security. This isn't just about stealing passwords. We're talking about breaking digital signatures, exposing encrypted emails, unlocking corporate and government secrets, and potentially even faking digital identities. If you thought a data breach was bad, imagine a quantum breach. And this isn't a hypothetical concern. Governments around the world, especially the United States and China, are racing to develop powerful quantum computers. They're also stockpiling encrypted data, assuming that even if they can't break it now, they'll be able to in the near future. This is sometimes called harvest now, decrypt later. It's basically like stealing a safe today because you know tomorrow you'll invent the skeleton key. This looming threat is often called the cryptopocalypse. A dramatic name, sure, but not entirely inaccurate. If quantum computers reach a certain threshold, what experts call quantum supremacy over classical cryptographic systems, it could be like the Y2K scare, except this time, it's real and no one has a nostalgic screensaver for it. So how close are we to this quantum leap? It depends on who you ask. Google claimed quantum supremacy in 2019 with a machine that completed a task in 200 seconds that would have taken a classical supercomputer 10,000 years. That sounds impressive, and it is, but that particular task wasn't exactly useful outside of a lab. The real game changer will be a fault-tolerant, general-purpose quantum computer with thousands, maybe millions, of stable qubits. Right now, we're at the stage where most quantum computers can handle a few hundred noisy qubits, which are highly sensitive and prone to errors. They need to be kept near absolute zero and isolated from almost any environmental interference. It's like trying to do calculus while balancing on a tightrope in a thunderstorm. Not easy. But progress is accelerating. IBM, Google, Microsoft, and multiple startups are making rapid advances. Some researchers predict we could have workable quantum machines capable of breaking encryption within the next decade. Others say 20 to 30 years. The point is, it's not a question of if, it's a question of when. So what are we doing about it? Well, the good news is, people saw this coming. Cryptographers around the world have been working on what's called post-quantum cryptography. These are encryption methods designed to resist attacks from quantum computers. Think of them as new locks that even the smartest quantum skeleton key can't open. The U.S. National Institute of Standards and Technology, NIST for short, has been running a multi-year competition to identify and standardize quantum-resistant algorithms. They've already selected a few candidates, and will likely see them rolled out in the coming years. But here's the problem. Changing encryption across the entire internet is like replacing every single door lock in the world, while keeping the doors open. It's going to take time, money, and coordination across governments, businesses, and tech platforms. And until that happens, a lot of data remains vulnerable. Also, quantum computers won't just be hackers' paradise. They'll also bring incredible benefits. They could revolutionize drug discovery, simulate complex molecules for curing diseases, optimize global logistics networks, improve financial modeling, and even help us tackle climate change. They're not all doom and gloom. Just mostly gloom if we don't prepare properly. Let's be real. If someone offered you a machine that could unlock the secrets of the universe but might also let your neighbor steal your crypto wallet, you'd be nervous too. So, what can you do right now? First off, don't panic. No one's quantum hacked your group chat yet. But if you're in tech, finance, cybersecurity, or just extremely online, stay informed. Encryption will evolve, and staying ahead of that curve is key. If you're a business, talk to your IT team about quantum readiness. If you're just a curious mind watching ThinkSpree videos, congratulations, you're already smarter than 90% of the internet on this topic. Also, remember that this is a human story as much as a technical one. We invented encryption. We'll reinvent it. Quantum computers are just the next chapter in the never-ending game of cat and mouse between data security and those trying to break it. So, will quantum computers break the internet? Maybe. But with enough preparation, innovation, and a healthy amount of caffeine, we might just build a better one. If this video sparked your curiosity, hit that subscribe button like a quantum particle collapsing into the correct state. Click the like button like you're stabilizing a qubit with pure enthusiasm. And ring that notification bell so you never miss a moment of the strange, wild, and mind-expanding content we're dropping right here on ThinkSpree. Thanks for watching. Stay secure, stay curious, and don't worry, if quantum chaos does come, at least you'll be the one who saw it coming. See you in the next one.